You ever wonder how a massive factory can spot a defect that's smaller than a grain of sand? Well, the answer isn't more people. It's about much, much smarter machines. Today, we're going to take a look inside a university lab that's bridging that huge gap between academic theory and the tough reality of the factory floor. Let's dive into the groundbreaking work of Professor Wang Yonghao's AI lab. So at the very heart of this lab, everything really boils down to two core ideas. First, mechatronics integration. You see, it's not enough to just write some clever code. You have to understand the steel, the gears, and the motors that the code is actually controlling. It's about that perfect blend of hardware and software. And second, real-world AI application. This means no research for the sake of research. Every single project starts with a real-world headache from a factory and ends with a practical solution. You can think of Professor Wang's lab at Minghassan University as this place where tough, old-school mechanical engineering gets a serious upgrade from the brains of modern electronics. And their mission? Well, it's to find the most frustrating, costly, and inefficient problems on the factory floor and basically engineer them right out of existence using smart, connected technology. All right, so here's our game plan for this deep dive. First, we'll see how they've given machines what is basically superhuman sight with AI vision. Then, we're going to jump right to the frontier to see how they're teaching robots to think using generative AI. After that, we'll dig down into the foundational engineering that makes it all possible. And finally, we'll uncover the 3 key traits that make this lab so darn unique. Okay, let's kick things off with what this lab is really famous for. They've essentially created an eagle eye for the modern factory, using AI to perfect quality control and catch mistakes that the human eye could never, ever hope to see. So here's the fundamental challenge, right? I want you to picture a production line with thousands of parts just zipping by every single hour. How on earth do you spot one single microscopic flaw? A human inspector is going to get tired, they're going to miss things. A machine, though? A machine won't. The lab solution is AI-powered computer vision. They specialize in a field called automated optical inspection, or AOI. And you can think of it like this. It's like putting a tireless, hyper-accurate inspector with a powerful magnifying glass at every single point on the production line. They've published a ton of research, all focused on building these systems that can spot defects with, frankly, superhuman speed. So how do they actually pull this off? Let's take a peek at their toolkit. For the brains of the operation, they use deep learning models like YOLO, which, by the way, stands for You Only Look Once, because it's incredibly fast at identifying things in a single glance. Perfect for a fast-moving line. For the eyes, they use OpenCV to process all the images. And here's the crucial part. All of this runs on small, efficient hardware like the Jetson Nano. This means the AI is right there on the production line. No need for some massive server in the cloud. It's fast, it's local, and it's incredibly powerful. And this isn't just theoretical stuff. I mean, look at these applications. They've built systems that can automatically measure the width of drill holes with unbelievable precision, spot tiny tears in paper tubes, check for uneven coatings on clips, and even make sure that microchips are placed perfectly. Every single one of these is a real solution, saving a real factory real time and money. So, if that's what they've already perfected, where are they heading next? Now we're looking at the future. This is where the lab starts to explore the real frontier of AI and robotics, and that means diving headfirst into generative AI. You can really see their whole technological journey right here. They built their foundation on traditional control methods, then they absolutely mastered computer vision with tools like YOLO, and now they're pushing into the next era with generative AI, using advanced techniques like RAG to give machines a completely new level of understanding. They don't just follow trends, they get there early. So what exactly is this new frontier? Well, it's built on tech like RAG, or Retrieval Augmented Generation. The best way to think of it is like giving an AI an open book test. Instead of just relying on what it already knows, it can go look up the latest, most relevant information to find the perfect answer. They're using large language models, the tech behind things like ChatGPT, and even visual language models, which can understand both text and images. And to make that totally concrete, check out this project, a voice interactive chatbot for their university. Now, thanks to that RAG architecture, if a student asks, hey, when does fall registration open? The bot doesn't just guess, it actively scans the latest university documents and gives a precise, up-to-the-minute answer. That is a huge leap beyond your standard chatbot. Their work in robotics is just as forward-thinking.
They're using advanced control systems for pinpoint precision and building on the industry-standard robot operating system. But honestly, the coolest part has to be this. They're using tools like Google's Media Pipe for gesture control. I mean, imagine raising your hand, and across the room, a robotic arm mirrors your movement perfectly. It's something straight out of science fiction happening right now.
Okay, so we've seen the flashy AI and the cool robots, but what holds it all together? What makes it all actually work? Now we get to the foundation, that bedrock of classic engineering that all this advanced stuff is built on. This is all about optimization and integration. And this is where that deep engineering expertise comes into play. They use statistical methods like the Taguchi method to run experiments and find the absolute perfect settings for a machine, right down to the thickness of solder paste. They use classic PID control to keep the temperature in an industrial oven from wavering by even a fraction of a degree. The big takeaway here is simple. Before you can automate a process with AI, you first have to perfect the process itself. And this right here is the key to understanding this lab. Their original strength wasn't just AI, it was this relentless, nitty-gritty process optimization. It's this legacy of precision that makes their AI so effective. You can't just slap an AI onto a messy process, right? You have to understand the physics and the statistics first, and then you enhance it with intelligence. The other piece of the foundation is integration. A smart camera on its own is useful, sure, but a smart factory? That's a revolution. So they focus on connecting everything. They build custom web dashboards to monitor the whole system, they use QR codes to track every tool and asset, and they even use smart home platforms like Home Assistant to link different devices together into one coherent network. The ultimate goal, the big picture, is to create a single, cohesive brain for the entire factory. It's about connecting every camera, every sensor, and every robot into one intelligent system that gives you a complete picture of everything that's happening, all in real time, all in one place. So, we've seen the vision systems, the Gen AI, and the deep engineering foundation. But what's the common thread here? When you boil it all down, what is the core DNA of this lab? Well, it really comes down to 3 key traits. First up, pragmatism. Every single project begins with a real, tangible problem. There is no research for the sake of research here. Whether it's optimizing a solder machine or spotting tiny flaws, the goal is always to create measurable, practical value for industry. The second trait is a deep, fundamental belief in mechatronics. Students here don't just live in the world of code, and they don't just live in the world of hardware. They have to master both. They are trained to be true integrators who understand the physical mechanics of a robot just as deeply as the Python code and AI models that bring it to life. And finally, the third trait, they are aggressive early adopters. This is not a lab that waits for new technology to become mainstream. No way. The moment something powerful emerges, like RAG or multimodal AI, they are immediately testing it, breaking it, and figuring out how to apply it to their students' projects. They live right on the cutting edge. And all of that leaves us with a really fascinating question to chew on. We've seen how this lab combines rock-solid traditional engineering with the absolute bleeding edge of AI. So as we look to the future, you have to wonder, when the deep institutional knowledge of manufacturing fully collides with the creative problem-solving power of generative AI, what incredible new innovations will be unlocked next?